So we've already done this part of our foldable. Okay, there it is there. We fold that up, fold this part down. We're going to put glue, whoops, on the back of it there. We're going to put it at the top of the page, so that way when we need to refer back to it, it's still inside our journal. All right, so some information you need to know about inequalities. If you're solving an inequality, good news is that solving an inequality is similar to solving an equation. So if we had the inequality x plus 4 is less than 7, we would solve it like we would an equation. We would subtract 4 from both sides. This 4 would be gone. And 7 minus 4 is 3. The difference here would be that we use this symbol instead of the equal symbol. And that's how that works. If we had 5x is greater than 25. Well, if it were an equation, I would divide both sides by 5. So I'm going to do the same thing. The difference would be I have this greater than symbol rather than the equal symbol. What if I had n minus 10 is less than or equal to 13? Well, if it were an equation, I would add 10 to both sides. And that would leave me with n and 23, and then this less than symbol. There is an exception, however. There's always that one exception. Here's the exception. Reverse the inequality symbol when you multiply or divide by a negative to solve. What those equations are going to look like negative 4p is greater than or equal to 12. We're specifically looking at if the number with the variable is negative, okay? Is negative and the operation is multiply or divide. Okay, so for this one I would divide by negative 4. Divide by negative 4. P and negative 3. So right here, I divided by a negative to solve this. Right there.
Mr. Chapman, please call the office. Mr. Chapman.
So I'm going to actually reverse this inequality symbol. And it will be less than or equal to -3. So if I had a problem that said t divided by -3 is less than 33, to solve that, I would multiply by -3 because that's what's with the variable, and that's what I've got to get rid of. And right here, to solve it, I have multiplied by -3. So that means this symbol is actually going to face this direction now. T, and then I've got -99. So t is greater than -99. Now, I'm going to give you proof as to why that works, why this is true. And I'm going to have to go on to the next page because I'm out of space here. Here's the proof. Let's start with just 24 is larger than 20. This is true. Yes? Okay, and let's say I added 4 to both sides. What would I get? 28 and 24. Is it still true that 28 is greater than 24? Yep. What if I added a negative? What if I added -3? This would be 21. This would be 17. And 21 is still bigger than 17. What if I started off with -2 and -4? The sign that belongs between the two of those. It's better to owe $2 than it is to owe $4. So if I added another -6 to those numbers, this is -8 here. This is -10 here. It's better to owe $8 than it is to owe $10. So this is still true. -8 is still bigger than -10. Okay, so let's look at what if I subtracted something. What if I had 11 and 13? Well, 11 is less than 13. What if I subtracted 7 from both sides? I would have 4 is less than 6. That's still true. What if I had the 11 was negative and I subtracted 10? Here I would have -21. Here I would have 3. -21 is still less than 3. It's still true. So I've added stuff, whether I started with a negative and added a positive or added a negative, it still came up true if I did it to both sides. So if I start with a positive and subtract something, it's still going to come up true if I do it to both sides. So let's look at multiply. If I start off with a positive 4, and 4 is less than 7, if I multiply both sides by 2, I have 8 and 14, and that relationship is still less than. What if I have negative up here? Negative 5 and positive 3. That's less than. What if I multiply those by 2? I have negative 10 here. I have positive 6 here. That relationship is still true. What if I divided? What if I had 20 and 24? And I divided both of those, this is less than, and I divide both of those by 4. I have a 5 and I have 6, and that relationship is still less than. It's still true. What if I had them as negatives? And I divided by 2. I have, this is backwards, sorry. It's better to owe $20 than it is $24. So I would have negative 10 and negative 12. And it's still better to owe $10 than it is to owe $12. Still true. Last two examples. If I start off with 4, 7, this is less than, and I multiply by negative 5, I get negative 20, and I get negative 35. Negative 20 and negative 35, this relationship is not right. It's not true. This is false. It is better to owe 20 than it is to owe 35. So here's how you know. I have multiplied by negative 5. So to keep it true, you have to reverse the inequality symbol right there when you multiply by a negative. Similarly, if I started with negative 51 is less than 21, and I divided both sides by negative 3, well, this will be positive 17. That's supposed to be negative. And this is negative 7. So 17 is not less than negative 7. This is false. So to make it true, we reverse that inequality symbol. So this is the proof that you reverse the inequality symbol when you multiply or divide by a negative. That's all we have for today. Thanks for listening.